Assalamualaikum warahmatullahi wabarakatuh and good morning everyone.
Morning, sir. Good morning, sir.
Alright, so this is a reminder. So we have midterm test. Another 2 weeks kan. In another 2 weeks we have midterm test on Monday 15 November from 8 PM to 10 PM. So what we are going to cover in the midterm test is up until this chapter, okay, the one that we are going to discuss today. Okay, which is problem solving using decision logic structure. Can you see my slide, class? Nampak tak?
Yes, sir.
Yes, sir.
So this one can be considered as uh, easy. Okay, easy topic. Consists of 2 part actually. So the first part we are going to finish on this week, and next week part 2 lah. So in part 1, basic decision logic structure, and then we are going to look at the types of if statement, if instructions. So there are 3 types actually: single selection, biselection, and multiselection. Okay, and then we are going to look at the overall picture. Okay, starting with we get the problem, okay, to be solved, and then we start with PAC, IC, IPO, and then algorithm, dash checking, flowchart. Okay, the same process that we gone through using the sequential logic structure kan. So to solve the decision logic structure, also we use the same elements, all these elements. Okay, next week, once we already settle with the basic decision logic structure, so we are going to look at three different what we call three different structure okay of how can we see this It is actually the same thing that we are going to solve, but we can solve it either using straight through logic, positive logic, or negative logic. Okay. Normally, okay, the common logic that we use for decision logic structure is positive logic structure. Okay, but let's say the question asks you to convert from positive to negative logic. So you must know how to do it. Commonly we use this positive logic structure. Okay, so later on we are going to see the difference. Okay, so let's start with the decision logic structure. Okay, the basics. So this is actually the algorithm. Okay, if you see the algorithm, in the algorithm mention the keyword if, meaning that it is a decision. And then after the if, it must follows by the conditions. And then we have the keyword then, and then we have else. This is okay. This is based on situation. Okay, sometimes we have if with else. Sometimes we have only if. Okay, if only. Okay, sometimes we have if, else if, and then follows by else. Else if condition. Okay. Else we have false condition. This is just to show you the possibility that we are going to have lah. Okay, if you see something like this is what we call as multi-selection. Multi-selection lah. Okay, if you see, there's if and then in between is if and else, there is else if. Okay, if you see if, it must follows by the condition. If you see else, there's no condition. You know, else stand alone without if, kan? If you see else if, then it must follows by the condition. If, of course lah, there's the condition. Alright. Okay, so this is what we call as multi-selection. Multi-selection with multiple condition, more than one condition. One condition, two condition. It can be if, else if, else if, else if, else if, and finally else. Multi, more than one condition. Multi-condition. Alright, so this is multi-condition. Okay, multi-selection. This is by selection. Okay, by selection, we have only one condition. Okay, and then follows by else. So this is by selection. Okay, we have else, if, and else only. Right? And lastly, we have single selection. Okay, this is single selection. We have if, no else. Okay, see, this is as a general. In general, we have three types of if statement. We call this if statement. So this is in terms of algorithms. Let's say we have this in the flowchart. So how do we identify the decision using the flowchart? For if statement, this is for if and else statement. So for single selection, okay, single selection, the flowchart is going to be looks like this. Single selection. Okay, selection we have diamond, kan? You still remember? So diamond is when we have a decision to be made in our program. Okay, so we have this. So let's say for single selection, so this is where you put down the condition. Okay, if you have condition. Condition, what is condition? Later on we look at what should be the condition. So this is the flowchart. We have if condition. If this is a single selection, okay, single selection. Single selection means that okay, we have true and then we have false. So remember, so for diamond symbol, you must have only two arrow comes out from the symbol. The first arrow is true, the second arrow is false. So you put it anywhere. Okay, you may put it over here. Okay, it's up to you how you design your flowchart. So let's say this is a true. If this is the types of if statement, okay, single statement. If true, it will do something. Over here, there will be a statement. Okay, the statements can be input, can be output, can be calculation, can be another decision, can be looping. Any statement, statements. So let's say this is a statement. Okay, statement. And then it will go back to its original root. Original root lah. it will go anywhere lah. Okay, maybe it will go to the end of the flowchart. It will go to the decision. It go to looping. It go to calculation. Okay, but this is true. So if it is false, where it will go? It go back to the original. Okay, without having any statements, no statements. Is it? You see? So this is tally with this. So if this is true, okay, true, and then if it is false, this is true. This is true. You need to label this. Later on, you need to label this is true T or you write down TRUE, true. So this is F, false, or FALSE. Okay, you need to label this. So if it is false, nothing happen. Same here. If it is false, nothing happen. That's why this is empty over here. Okay, you get it? Single selection. This is just to look at the structure first. Okay. Single selection. Of course, there will be over here, there's arrow comes in. So it can be inputs, calculation, up over here. Alright, so this is single selection. So we have, tadi we have malas saya nak type. Okay, single selection. Alright, and then we have multi-selection. So multi-selection tadi, sorry, not multi, bi-selection. So bi-selection is where we have else, remember else no condition. So else no condition. Okay, but it will have instruction. Okay, so this is by selection. Okay, where we have true instruction, there is a instruction if it is true. If it is false, also there will be instruction. It can be instruction or instructions. It can be single instruction or maybe more than one. For example, more than one. There's a calculation, there's a calculation, there's a calculation, or it can even have like I said, so it can have anything. It can have looping as instructions, or it may be another decision over here. Okay, instruction. Instruction can be anything. Okay, so this is what we call as by selection, meaning that if the condition is true, there's an instruction or instructions. If it is false, also there's an instruction. So any instruction you have over here, you put it in here. So if it is more than one instruction, Instruction 1, instruction 2, okay? Same goes over here. So if it is false, if this is a by selection, so you have this instruction over here, okay? More than one, list everything over here. Do you get it, class?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Another one is multi-selection. Okay, so multi-selection is when we have else, if n. So if there's an if over here, then we need to have condition n. Conditions. Okay, and then this is true lah. If it is if kan, cannot put else false over here. False is only applicable for else. And then it must be closed with else. Else statement should be nothing over here, no condition. We can say that else is the ending for the if else if lah. If else if, it must end it with else. So else will be the false instruction. Cekkan sikit lah ni. Sikit. Okay. Alright. So over here, if condition is true, then it will execute. Okay, same goes over here. It will execute the instruction. Let's say we have two instruction. First instruction, second instruction. So if this is false, okay, you see, if it is false, it will go to the next condition. Next condition. So condition must have this symbol lah. Okay. So condition. This symbol lah. So if it is false, it will go to this symbol again. And then it have its condition lah. The condition. And then if it is true, it will do these instructions. This condition belong to this condition. True for this condition. For this condition lah, in this case. So if this is true, then it will do the instructions. For example, this one this. Okay. And then we'll go back to its original part. This is the original part, so it will go over here back again. Okay, so if it is false, it will go to here, false statement, false instruction. So false instruction over here. This is true, this is false. Okay, this is true. Okay, true, this is instruction for true, this one. If it is false, it will go to this direction and it will execute this instruction. Okay, this instruction. Okay, this instruction is over here. Okay, it can have more than one instruction. Okay, it can be this one, can be another calculation, it can be input, it can be output, it can be decision, and so on. Boleh kelas? So this is multi-selection. Multi-selection when we have more than one diamond symbol. More than one kan? More than one. So this is multi-selection. Alright? So multi-selection can have more than one diamond kan? So it can have 3, 4, 5, 6. Okay, for example, we have another condition over here. Okay, let's say the condition is else if. Else if kan? You see if, so it must follows by condition. Okay, and this is true lah. So for if, it always true for the condition. Unless you see else, okay, else should be the ending for if statement. It must end it with else. Okay, it must end it with else. Okay, you cannot end this statement with else if. No, this is wrong. Okay, I will show you why this is wrong. So let's say you end this with else if. Okay, so we have 1 condition, 2 condition, 3 condition. 3 condition. So this is this one. Okay, this is condition, this is the condition. So this is the condition for this one. If it is false, okay, this is true kan? If it is false, so it goes to another condition. Okay, so this is the condition for this diamond. This is the condition for this diamond. Okay, so if it is true, it will go to will go to its own instructions. This is its own instruction. This is the instruction. Okay, over here belong to this diamond. This diamond over here. This is the instruction. Okay. Okay. So this is the instruction. If it is false, so what is the instruction? So we must put the condition for this is false. We must give a statement over here. Okay. Don't leave it hanging. So this is hanging. If it is false, what is the condition? So we must put the condition for the false. False only covered by else. So else we have the false instruction. Then we can put instruction for this one. So the instruction is the false instruction over here. Okay, if this is false. Okay, if this is true over here. If this is false, it's over here. So you see we have 1, 2, 3 condition covered by, okay, this one 1, 2, 3 condition. Okay, so this is true, true, true. Okay, so this is true, true, true. Okay, and this is statement for false, last false. Okay, this is this one false. Okay, false here got nothing kan? False here got nothing. False here got statement. Okay, class. General structure. Boleh?
Boleh sir, boleh.
Okay, later on we see what's the condition should be kan. Okay, so condition. What should we put in the condition kan? So let's say we have a single selection. Okay, we have single selection over here. What should we put inside of it? We know that we need to put if kan. So if the keywords and then follows by the condition kan. Condition. So the condition can be this operator, but it must, the output should, okay, be the true or false. The output cannot be number, it cannot be alphabetical, it cannot be a string. Okay, the output that we put over here, which is the expression, expression should be true or false, because we want it to be true or false kan. You cannot put number and 1, 2, 3, no, cannot. It can be only output true or false only. Okay, meaning that, let's say the expression is you put this over here, if okay. So this is wrong. Okay, this is wrong. So what is right? So this is how to make it right. This is equal. Okay, refer back to the rational operator kan. So this is equal. This is meaning we want to compare left to the right. Okay. If this is the operator use, this is to give the value from right to the left kan. This is to compare. Alright, so this is correct. Okay, you want to compare X with 2. For example, over here we have input enter X. And then we check whether X equal to 2 or not. Again, so if X entered over here is 2, okay, let's say user entered 2. So is it true or false?
True.
True kan? Okay. True. So what will happen if it is true kan? So let's say user enter 3 over here. Okay, 3 equal to 1 plus 1. False. False kan? So false, it will go, let's say over here. The statement over here. Okay, so these are the operator that is for this one lah. Okay, how we want to use and or not kan? So for example, we have two conditions. Both must be true. Both must be true, so we use and lah. And then we put the condition over here, the expression over here. So what's the expression? For example, Z also must be equal to, example kan, 1 plus 1. So both condition must be true in order for this decision to be true. Okay, so for example, user need to enter X and Z over here. So both must be true. User enter X2, user enter Z2, the value kan. So it check X equal to 2, okay, true, and Z equal to 2, true. Okay, so both true and kan, that's why we use and. Both true and then it goes over here, okay, true statement. Ini true kan, ini false. Okay, if you want the both statement to be either true or false, it's going to be true, you use or lah. For example, X2, Z1. Okay, this is true, this is false. So for or kan, or true or false, it's going to be true kan, so true. Okay, same goes over here lah. So let's say the condition must use more than, for example. Okay, so we use this condition. Okay, so the expression output should be true or false only for the condition. For the condition, okay, that use expression, the expression should be true or false output only. Okay, so this one cannot be used. The output for this is numeric kan? Cannot be used. This is to compare. So this is allowed. Boleh? What should be put as a condition, class? Anything to ask over here for the condition? Okay, good. Tak ada Alright. So this is okay, same like what I explained earlier. This is basic expression kan. Of course, A and B, if you want to put it in the expression, so the data should be in the same data type lah. Okay, and then ada apa lah ni? Okay. This is the same thing. Okay. What should you put in the conditional expression? In the end, the output of this statement should be either true or false only. Okay. Cannot be numeric. Alright. This is already I explained earlier. Okay. We have another one over here actually. Okay. We have tadi tu lah. If, else if, it can have more than else if. Not fixed to if, else if only. This is multi-selection. And then ended by else statement. 4 1, 2, 3. So this is a fourth statement over here, case instruction. You edit your note later on. Okay, this is a fourth. This is, we haven't discussed this yet. So we have 4 actually. So this is the same type. Okay, using if, else if, using if lah, if statement. We have single if statement, we have by if statement, we have multi if statement. Alright. The example tak? Okay, so let's say we have example. Okay, ni single lah. Ni repeat again. Tadi we look at without example kan. This one we have example. Okay, so this is single if statement. Okay, single if statement. Let's say the question asks you to develop a system to check the student attendance. Let's say if the student attendance less than 65, okay, if it is true, then we do the calculation over here. This is the calculation. Okay, this is the calculation. If the student attendance is more than or equal to 65, more than or equal to 65, so nothing will happen. Okay, you see, no statement, nothing will happen. Okay, nothing will happen. Okay, if the total number of students less than 65, not including 65, less than 65, meaning that 64 and below. Okay, 64 and below. So let's say the input over here is, okay, the input over here is student, for example, so user enter 65 over here. Okay, so based on this condition, 65 is true or false, guys? User enter 65. So when it comes into the decision, is it true or false?
True.
False.
This symbol, this means less than, not equal to 65. It must be less than 65 in order for it to become true. So if it is 65, it's equal, it's not less than 65. It's equal with 65. So it's considered as false. If it is 64, then 64 is less than 65, true. Then it can go to this instruction over here. If it is 65, false. 65 is not less than 65. 65 is equal So 65 is not less than 65. So false, then it do nothing. Okay, it go to the next statement over here. For example, there's another statement over here for sorry. Okay, I have a question for you. So let's say if there's a statement over here. Over here, okay, you see? And there's a calculation. For example, A equal to B plus C. Okay. So my question is, if the value of student is 64, A65, A64, okay, sorry, 64, okay, user enter 64. Okay. Okay, this statement A equal to B plus C will be executed or not? If the value of student is 64, the statement A equal to B plus C will be executed or not?
Yes.
Yes.
Yes. Yes, okay, correct. Okay, so you see, 64, if student less than 64, correct? Yes. Okay, so execute this and then execute this. Okay, let's say the value is 100. Okay, value of student is 100. Okay, enter student. Okay, user enter 100. Okay, enter using keyboard lah, 100. Okay, this statement is going to be execute or not?
Yes.
Yes.
100. Yes. Yes or not?
Yes.
Okay, let's check. So 100. Okay, 100 is not less than 65. False. Go here, and enter this. Okay, still execute. Although this statement is false. Unless if, let's say, the arrow comes over here. Anywhere lah, over here. It skip this one. So, let's say the value of student is 100. Okay, 100 false. Now, is it going to execute A equal to B plus C, class?
Yes.
Is it going to execute A equal to
No.
B plus C?
No.
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 No lah kan? Because you see the arrow skip the statements. Okay, this is just to show you how you design your program. Even a single mistake, will affect the whole program. So if it is supposed to execute this for both condition, true or false, so you must put this arrow over here. Meaning that both condition will execute this statement. If you want it to be executed only if it is true, then you don't put this arrow over here. You put it, skip it. Okay, skip the statement. And then okay, it should be like this. Arrow. So it will skip. If you want this statement to be executed only if it is false, you put it over here kan. But in this case, single selection, no statement. Okay, for single selection, no statement. No statement. So let's say if this is the situation, so okay, if this is a situation, is it still considered as single statement, class? Is it single or it already become by selection? Is it single selection or by selection?
Bye.
Over there? by selection where we have condition on both sides kan. For true we have for true we have instruction, for false we have instruction. So in this case, is it by or single?
Single. Single.
It's still single Okay, you want to see it clearly? Look at the algorithm So the algorithm, where should I put A equal to B plus C class? Where should I put A equal to B plus C?
Under student count.
Under student count. Okay, let's say if you put under student count. Okay, let's say we put it over here. Okay, if you put it over here, meaning that if this statement is, if this condition is true, then it will execute this. You see? So if this is false, is it going to execute this?
No.
No, kan? You see the flowchart. If this is false, is it going to execute A equal to B plus C?
Yeah.
Yes, kan? Still execute kan? So can you put it over here?
No.
Cannot Okay. If you put it over here, meaning that the flowchart is going to looks like this. Okay, if it is false, it will skip this one. So if this is a situation, then this is correct. Okay, this algorithm is correct. If this is the flowchart, if false, it do nothing. But in this case, my question, if this is the flowchart, so how the algorithm is going to look like kan? Macam mana?
Letak bawah.
Tak bawah?
After and if.
Tak bawah? Below?
Below
And
and if.
Alright. Okay, we put it over here. Okay, so that if it is true, okay, true, it do this statement, and if it do this statement. If it is false, it do nothing. And then it goes over here. Alright? So what happen if I put this over here? Anybody?
Else.
Okay, good. So if I put over here, meaning that we have statement if this is false and okay, we have statement if this is false. So the statement for false is else and so we must put else without condition else without condition. Don't forget, don't put any condition over here. And then we put the false statement over here. False statement over here. So this become this algorithm. Okay. So it is not a single anymore lah. So this is by lah. Okay, by selection. Boleh? Okay, become by selection. Any question class? Ada yang confused kan? Anybody confused up until this point over here? Tak ada Okay, so this is by, okay, by selection. Okay, next we are going to look at the example for multi-selection. Multi-selection where we have more than one. More than one kan? More than one symbol kan? So let's say we have, okay, so for, we know that by both condition true or false must have instruction. So for multi, ni nak guna balik kan ni, tak sini So for multi selection, we have another condition over here. If true, it will do its statement. Okay, if true, it will do its statement. But if it is false, it go to the next condition. Okay, when we say that it have condition, condition must be follow, okay, from if. Okay, you must have if, then we must have condition. We can have condition. No if, no condition. Else only, no condition. We have if, must have condition. Okay, right after if statement. Okay, same goes over here kan. If, you must have condition. We have if, we must have condition. Condition, we have to put condition inside of diamond. That's why we have diamond. Because we have condition. We have condition, we have diamond. Okay, no condition, no diamond. Okay, so for example, with the condition, students equal to, ini tak logik kan, but just for example kan. Then A equal to B plus C. So how do you want to make it a flowchart? Just put the condition over here lah. Okay. Student equal to 100. Ada mana ni? Okay, so you must have true or false kan? Okay, you must have true or false. Okay, for example, this is false. This is true. How you want to draw it? It's up to you. You may put false over here, true over here. It's up to you. But you need to label lah. Label is very important. Okay, so this is false. So this is true. This is true. Okay. So in this case, if it is true, what will happen, class? If it is true, what will happen?
A equal to B plus C.
Okay, A equal to B plus C. Okay, and then it will go to the same direction as A. Okay, sorry lah. Ni. Okay, we go to the same direction. Okay, in the end, it will meet this. Okay. For example, go to anywhere lah over here. Calculation ke, input ke, output ke, decision ke, looping ke. Any instruction can be over here. So, if you just submit this design class, is it correct or wrong? Look at this, look at the flowchart. Is it correct or wrong? Biar saya tanya ya.
Wrong.
Correct or wrong? Arif Iskandar. Arif Iskandar. Tak jawab kira abstain Boleh?
Yes, sir.
Ada. Arif Iskandar. So, is it if we say that this is a final algorithm, is it correct or wrong? Ya, Arif.
Wrong, sir.
Okay, wrong. If it is wrong, what's missing? Why is it wrong? Boleh, Arif? Why is it?
Sebab dia ada then, tapi dia ada as if.
Supposedly?
Else if. Terus and if.
Tak ada else if. Macam mana? Macam mana? Salah tu. Explanation tu salah. Chi Jianing.
Yes.
This algorithm, is it correct or wrong?
Wrong.
If it is wrong, why is it wrong?
The false part missing.
Again. The
False part.
false. Okay, so what should we put over here?
Else.
Else, correct. Okay, correct. So you must put else lah. Okay, for multi-selection, it must ended with else. Okay, it doesn't matter how many condition you have. Okay, this one we have 2 and let's say you have 3, so we have another condition. We have 4, we have another condition. But in the end, we must end it with else. Okay, so else is so that we didn't left this false hanging. Okay, this is hanging. Okay, it should have instruction over here because it is multi-selection. Multi-selection you must have over here. Okay, we must have instructions. So how can we put instructions over here? By putting else. Kan? For example, we have instructions. If it is false, this is the instruction. Example, kan? So it goes over here and join the rest over here. Join the rest meaning that join if this is the statement for true. This is false. It will in the end we go to the same direction. Okay, because this is the same sets of decision. Okay, the same sets. Okay, when we say that the same sets, it will go to the same parts in the end. Okay, you cannot put this is one part, this goes to another part. Cannot, because it is the same sets, same sets of decision. Okay, unless it is come from different set of decision, then it may go to the different direction. Alright. So for the algorithm, else no condition. That's why else it is empty. No condition, empty. So we do the false statement. Okay, the false statement is A equal to Z plus C. Okay, then finish lah. So this is false statement kan? False statement. Okay. So we can have more than one statement over here. One statement, two statement, three statement. Okay, the statement can be input, can be output. Okay, ni pun nak kena tunjuk ni nanti kan. For example, we have input example kan. Enter B. So over here we have enter B. Example Okay. Indent. Okay, so this is where indent is very important class to differentiate the hierarchy. Okay, so this is the parent, indent slightly to the right. Okay, just to show that this statement over here belong to the parent over here. Okay, this statement over here slightly to the right and the same level as this one. Okay, same level to indicate that this is belong to this parent over here. Okay, same goes to the rest Indent indent is very important for algorithm. Okay, now this is the multiselection. Itu je lah. Okay, very simple Alright, so over here is missing missing apa This one is missing. So we have single, we have biselection. The one that we are missing is multiselection in this explanation So this is another example. Okay, another example. Okay, for bi. Okay, for biselection So this is the conditions. Okay, conditions. Status ini class equal. Don't use is Jadi sedukut kat kan algorithm So this is algorithm Status equal to pass, status equals to fail. So this is the flowchart. Okay, next is case logic structure. Number 4 Number 4. Okay, case logic structure. Okay, case logic structure is also a kind of decision. Okay, decision structure. However, okay, it is only applicable for the data type of integer and single character, not the string Let's say if you have integer or character, okay, you don't want to use if else structure, you want to use case logic structure, and then you can use it. However, if your data is floating point number over here, okay, with decimal okay, number with decimal 1.2 ke 10.5 ke float apa panggil apa numeric numeric apa float floating point number so you cannot use case logic. Okay, you must stick with the if statement. Float cannot string also cannot use case logic structure, cannot use this. Where float and string appear that you cannot use this, inside of here in the decision. If inside of the decision you have float and string, you cannot use case logic structure. It's not in the note slide in class. So add this information. Okay, you may use it if it is integer or it is single character. Then you may use this kind of structure. Okay, how is it different from the one that you just discussed? Okay, for multi-statement, okay, for multi-selection, if you are using if statement, you have more than one decision symbol, diamond. But if you are using case logic structure, although you have multi condition, okay, it only have one single diamond on it. How to write it? Okay, let's look at one example. Okay, supposedly we have, for example, okay, this is the example. Okay, example, we have example. Example, we have example guy. We have med code. Okay, this one. An insurance company has 4 different medical plans. Okay, the programmer has given each plan a code corresponding to the beginning initial of the company. Plan 1 is F, plan 2 B, plan 3 K, plan 4 E. So the company pays for all of plan 1. The individual has to pay for partly lah ni. Partly of the others. Meaning that plan 1 fully paid by the company, the rest of the plan the individual need to pay part of it. So how much part of it kan? For example, plan 2 user need to pay 4.65. The rest will be paid by the company. Betul kan? Plan 3, 7.89. Plan 4, 5.5. Okay. Any other codes are considered in error. For example, user enter plan 5. No lah kan, error. So write the algorithms and draw the flowchart for payroll deduction. So what is the input class? What is the input? Anybody? Input?
Plan.
Plan, correct where is it? Okay, this one. So let's develop the full if else statement first. So this is start, and then we have inputs over here. Okay. Plan kan? Example of the input value. Example of the input value.
FBKE.
Okay. FBKE. Inilah. FBKE. Follow yang tu So example of the input value is FBKE. Not 1, 2, 3, 4 don't get confused based on this statement over here. So this is the requirement So the input should be F BKE. Input for plan kan. So over here, input is enter what? Enter?
The plan.
Enter plan lah. Okay. But if you want to synchronize with this one, the input is what class? Mat code. Okay. Mat code Mat code. Okay, mat code. And then after that, using if class. After input mat code, then what?
If mat code equal to 1.
Alright, so we have condition. Ni ada arrow lah Malas pula nak buat arrow ni. Arrow comes in. Okay, so we have if mat code. If mat code. Apa? Apa kelas? If mat code
Equal
Equal to 0.
equal to F.
Equals to F.
Equal to F.
equal to F lah okay. F is for plan 1 kan. F. F. Sometimes we have single quote for single character. Okay, some platform platform for coding lah. We use single quote kan. Some platform we need to use double quote. For this I just use double quote Okay, then if it is true, what will happen? If it is false, what will happen? This also need to label Baik pula nak buat ni Label. This is true. This is false. So if it is true, what happen? Tengok ni. What happen?
Mat deduction equal to 0.
Mat deduction equal to 0. Okay. Equal to 0. If it is false, what happen?
Condition.
If else if.
Else if. And else if put equal to B. So if it is true, what will happen?
Mat deduction equal to 4.65.
Okay, correct. Ni label label true, false, Ini saya malas 4.65. So if it is false, what happen?
Else if.
Else if lagi kan. Make code equal to K. So if it is true, what happened? Deduction equal to how much, class?
7.
7.85. If it is false, what happened?
Met code.
Are you sure?
Deduction equal to 5.50.
Kan? So this is common mistake. Sometimes you will do this mistake. You put another one over here, which is wrong because you will have, if this is true, make deduction equal to 5.50, but for false, what's the value? Betul tak? But in this case, this is correct. In this case, this is correct because mention this one. Any other codes are considered in error. Okay, maybe this is correct because this is involving another function. This is function. We are not yet discussed, but this have another function over here. Okay, so we follow this one. So we have function over here, meaning that if this is true, we have another else if. Okay, we have another else if. If this is false, it will go to another function. Function, if you still remember, so the function symbol is this one, process error, for example, process error. Okay, so if, else if, else if, else if, else. Okay, else, process error. Okay, so this one correct unless it doesn't mention over here. Okay, so the else should be this one. So there will be no this. Okay, no else if met code equal to k. Okay, no this one. Straight away it will. Ini class. Okay, execute this one. Ini pun tak ada lah. If this statement is not mentioned over here, for example. Okay, so this is the common answer lah. Okay, let's say we remove this. Remove. Okay, so this is the answer. Okay, so let's say, okay, this is, okay, so my question is, after comes out from the true, so where should this go? The arrow. For example, this one, this one arrow. Okay, how can we make sure it like this? How can we make sure that in the end everything will go in the same direction? Okay, can I do it like this? Okay, this one, is it correct or wrong? Okay, I put the arrow over here. I put it over here. Then I put it over here. and then I put it over here. Then every direction will go in the same direction. So my question, is it correct or wrong?
Wrong.
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 Why is it wrong? Why is it wrong? If this is wrong, so what's wrong with this? Anybody?
After mat deduction 0 tu, the arrow should not go to the mat deduction 4.65.
What happen if I do it like this?
So tak sama dengan algoritma. Macam mana? Dia akan rosak.
Okay. Okay, wrong lah. Okay, correct. This is wrong. But you need to understand why is it wrong. Okay, first, let's say if user enter mat code equal to F. Okay, supposedly mat deduction value if mat code equal to F is what? Class? 0 kan? Okay, supposedly mat deduction value equal to 0. But if you put it like this, now mat deduction become 4.65 instead of 0. And now the mat deduction becomes 7.85 instead of 0. So the last value for mat deduction is what?
7.85.
7.85, not 0. Okay, you see? Supposedly 0, but when you put it like this, the value has been changed, and the final value is 7.85 when user enter mat code equal to F. Okay, wrong lah. So how do we okay, this is common mistake. I'm showing the mistake that some of you will do in the future. Okay, so make sure it is independent lah. So after you get this, don't leave it hanging. Okay, hanging. So it must go and somewhere. So the arrow should go somewhere lah, but should be in the correct direction. Okay, go somewhere. Okay, go somewhere, but in the end, it will go in the same direction. Okay, macam ni boleh. Okay, kelas. So probably over here we have maybe line, maybe we have calculation, or maybe we have simply print kan, print mat deduction kan, for example. Print mat deduction. Then N. Okay, so this is normal if else kan, but we do this so that we can compare with the case logic structure. So let's say you need to construct case logic structure instead of if else statement. So what you need to do is this one lah. Okay, so you must have one condition. Okay, and then inside of it, you put what do you want to test as a condition. Okay, in this case, you want to test the condition for mat code kan. Mat code is the same condition. So in the case logic, so you put the variable that you want to test over here. Okay, and then so we have 1, 2, 3, 4. This one we already delete we remove this then. So no more So no more. Okay. No more. Right. So compare with this one. So this is if mat code equal to F. So when we convert to this structure, we put the condition over here, equal to F. Okay, so if this is true, we put the value of mat deduction. If this is true, okay, if F is true, we put this over here. Okay, so the statement can be more than one statement lah. So let's say over here, after mat deduction equal to 0, we have calculation. A equal to, for example, over here we have instruction. A equal to B plus C. Then goes out over here. Okay. Okay, understand After mat deduction equal to 0, we have A equal to B plus C. So same over here. So we must have A equal to B plus C over here for F only, kan? Alright. Okay, same goes to the rest lah. B, K, but this one is reserved for else. So else we put otherwise. Change the keyword only. So otherwise mat deduction equal to 5.50. So we take this as else. Okay, over here. Else mat deduction equal to mat deduction equal to 5.5. This is true and this is true, this is false. False, mat deduction equal to 5.5. So else over here, when it comes to case, logic structure, we change to otherwise and we put the value for the false over here. So this is for else. And then altogether comes to the same direction. So let's say if we have print over here, and like we have in the if else statement. So we have print over here. Output print mat deduction, capital letter so it must follow the over here, capital letter lah, saya malah tukar mat deduction, and then exit. Okay kelas? Boleh?
Boleh.
Boleh.
Okay, in terms of algorithms, so this is the algorithms. Okay, case of missing mat code. Mat code. Okay. Then you list down all the mat code decision. So this is if mat code. This is else if, and this is supposed to be apa? Ini we already delete this. This is supposed to be otherwise. Kan? Otherwise and then we have print and over here we have print mat deduction. Okay, you see the label same like this don't put it slightly inside because this statement is not belong to end of case so this is over here. Okay, boleh This one we have what missing over here? Enter kan? Enter. Enter what class? Enter. Enter what? Anybody?
Make code.
Math code.
Input kan? Same goes over here. This is missing enter make code tadi So over here we have, if you want to make it the complete kan, this is just only taking part of the program kan. It is a complete program. We have input, enter make code kan. Same goes over here kan, enter make code. Alright. So this is another example that you may look at. Okay, you see if the value of the condition is in the form of single character or integer, okay, you may use the case logic structure. Okay, you may use, but if you want to use normal if else structure, also can, it is the same. But if this is, the value is in the form of decimal letter, a decimal number, okay, with floating point, or a string, so you cannot use case logic structure. Okay, have a look at this example. It's same example, but this one got calculation. Okay, so this is to summarize, but there's missing one thing over here, the multi-selection. Multi-selection, we have if, else, okay. Alright, comparison on the flowchart. Also missing multi-selection for if. This is only single, this is by, we have multi, where we have more than one condition symbol. Alright. So once you know the different of the decision structure that we have, then you may start solving the problem by following the flows of the elements. First, you need to have PAC, IC, IPO, okay, algorithm, dash checking, and so on. All right. Okay, example. Example, we have this simple problem. Assume that you are calculating pay at an hourly rate and overtime pay at 1.5 times the hourly rate. So how do you solve this? By using a computer system. So you are asked to create PAC first. So this is the PAC looks like. Okay, given data is the same. Okay, like the sequential logic structure where we put input. So the input is hours and rate. Required result also the same where we put output. The only difference on the PAC, if the solution involving decision is on the processing part. So you need to include, the condition over here. You have one set of condition, it is like this. If you have more than one set of decision, first set over here, second set over here, third set over here, okay, list down all the possible condition inside of the processing section. Okay, so let's say this is the condition, if hours more than 40, okay, if hours more than 40, meaning that it is overtime, then the calculation should be like this. For example, if it's a normal hour, this is the calculation. Simple if else only. So this is the PAC. Okay, PSC will show the decision. How about the IC? IC doesn't show any condition. Okay, it doesn't show where the condition is. Okay, unless that one we will discuss later on in chapter programming structure, chapter function and module. We're going to look at the possible to put condition inside of IC. But for now, just assume that IC doesn't have any condition. Okay, the decision doesn't show in the IC. Okay, in the IPO, of course, the IPO will shows everything. So IPO, okay, we have input and input. Okay, and then we need to details up the input process. Okay, enter hours, and then we put the module name, no output. So please remember back this one, no output. And then we have input, the second input, okay, the process, okay, enter, and then the module for input. Okay, over here, before we do the calculation, we have the decision. So the decision, so we put it in the module calculate, for example, so the condition is within the calculation. Along with the calculation, we put in the module calculate. So you may put this one, or you may put in every line in the same. For example, this is for statement 3, for statement 4. Okay, in the module calculate. So we have else in module calculate. Okay, this is in module calculate. In line 8 also in module calculate. Okay, line by line, we put it specific in module calculate. So we have a module calculate. So everything in module calculate. Ke bawah pula ni. Okay. And lastly, we have print pay. Okay, in module print, it's supposed to be in line. Ni dari ke bawah dah ni. Kenapa kan? Okay, this is for print. And print, we have pay. So pay is the output variable for print. Print only we put output. Please don't forget this. Don't put pay in input or calculate. Wrong. Put it in the output process only. And finally, end, the system return to the main module. So this is the main module. Okay, it's supposed to be the same as this name over here. Okay, control main module. Okay, that's it. That's the only difference. On the PAC and IPO, you need to include the decision. Alright, then comes out the algorithm. So algorithm we already cover. Okay, algorithm. However, how algorithm is written over is not really correct. For example, this one supposed to be in the same line. Okay. For example, this one slightly to the right. Input. You guys faham Ini ke kanan kanan susah pula nak ke kanan. Oh, okay. Apa ini ke kiri, but if need to be slightly to the right, it should be in the same line. This one same line make it the same. Okay, this is also in the same line. Okay, because it is the same level. Okay, so this is the algorithm. Okay, next is the dash checking. So what's the difference of the dash checking compared to the sequential logic structure? The dash checking we need to include one more column, which is condition column. The rest is the same. Okay, we have line number, we have the listing of all the variables, we have input or output. The one that is different over here is where we put condition column. Okay, so how do we read this one? Okay, so this is the algorithm. Okay, this is the test data. So test data input, hours is 5, rate is 30. So in line number 2, input hours 5, line 3, input rate 30. Okay, so in line 2, hours 5, rate 30. The same So in line 2, hours 5, okay, you must put this one indicating this is the input. Okay, rate 30 in line 3. Okay, line 3. And then in line 4, straight away we have condition and okay, so over here you must test the condition. Okay, 5 is what? 5 is hours in the condition. Okay, you put this, but you take the real value. Okay, 5 and 5 more than 40. Hours and hours is 5 and 5 more than 40. Okay, hours is 5 more than 40. Is it true or false? Okay, so you put is false. Is false, what will happen? If this is false, so it will skip. If this is false, it will not execute this statement and this is only for true. That's why you see it skip line number 5. So this is very important. You see, now line number 5 is empty because it skipped this since the condition is false. Okay, very important over here. Don't make this mistake. And then it will go to line number 6, which is else. So else got nothing over here. Just else. So if this is false, which is correct, this is false and this is not true. 5 more than 40 is false. So if it is false, it will execute line number 7. That's why over here you see we have line number 7, the equation process. Okay, we get the real value from this equation over here. Okay, what's the real value? This is the value. Okay, and then line number 8, we got nothing. Line number 8, this only an if. So we skip this. And in line number 9, display the value of pay. Line number 9, okay, display pay equal to 150. Okay, you got it, class? How to read it? Okay,
Yes, sir.
Okay, what if we use the value true? So this is the value if it is true. Okay, hours 42, rate 30. Okay, so hours 42. So this is true. Okay, hours 42, rate 30. In line 4, the condition is true. Okay, the condition is true, so we put T. That's why over here we have the statement in line 5. Okay, over here we don't have statement in line 5 if this is false. Over here, since this is true, so we have a statement over here for calculating pay. Okay, over here calculating pay in line number 5. So we get the real value. Okay, so this is supposed to be equal to 1290. Okay, the rest of the line we skip because we got this one true already. We got this true already. So we skip this, we skip this, we skip this, and straight away to this one. Display pay. Okay. So it's different. It's different table if the condition is true compared to the condition is false. Okay. Later on, have a look again in this table. Make sure you understand this how you construct a dash checking. Alright. That's all. So this is a flowchart. This one is missing print. Supposedly there's a print over here. Before n we have display pay. Display pay. Okay, the rest is the same. Okay, and have a look by yourself for this example. Okay, try to do the algorithm, flowchart, and dash checking. Okay, this is another example. All right. So this is slightly different. This is, we can say that another way to do it. Another way to do it, as you can see over here, this is the condition if, else if, else and. So you may put this in the processing over here, or you may put the condition as a statement, as a maybe you can put table over here. Okay, you copy and paste the table in the given data. Okay, this is another way to do it. Okay, in the given data. You see, there's no condition over here, but the condition have been put in the given data. Also can, and any way that you prefer. Okay, PHC. Okay, try to do the algorithm and dash checking for this one. That one is for your own study by yourself, okay, later on. Okay, that's all for part 1. Any question? PHC ke apa nak tanya? Dash checking. Is it clear, class?
Yes,
Clear
sir.
tak? Decision.
Yes, sir.
So no question No question 1, no question 2, no question 3. Okay, so if no question, okay, then fill in the attendance form. Okay, no condition else if. Oh, saya dah missing ni, apa benda ni? Since I'm sharing my screen kan, class, so I cannot see the chatting. So if you have any question, better you ask me directly. Okay, don't use the message. I cannot see it when I present my whole screen. Okay. Right, so that's all for today. Thank you and Assalamualaikum.
Thank you, sir.
Yes, sir.